A sequence here is defined by this. Write down the values of u1, u2, u3. Find this sum. Given that u1, u5 and up are respectively the first, second and third terms of a geometric progression, find the value of p. Find the sum to infinity of this geometric progression in part 3. So here's the question then. Let's have a little look at it. So just write down u1, u2, u3. So u1 is equal to 85 minus 5 times 1, which is 80. u2, 85 minus 5 times 2, 75. u3, 85 minus 5 times 3, which will be 70. Okay, so part 2, find this sum. So we're adding all these then. So this would be the sum of the first 20 terms. S20 is equal to, so here we've got A, the first term, is equal to 80. The common difference D is equal to minus 5. And the number of terms from 1 to 20 is n equals 20. So S20 then, using the formula, n over 2. Then let's just put it in a different color to start with. So it's n over 2. 2a plus n minus 1d is the sum. Okay, and then we'll write it underneath. I think that's the best thing to do there. So let's put the numbers in. So that's equal to, n is 20. So that's 20 over 2. 2a, 2 lots of these is 160. Plus 20 minus 1 is 19 times the minus 5, which is d. So that's equal to 10. 20 over 2 is 10. 95 minus 95, so we've got 160 minus 95 is 65. Times 10 is 650. So that's that. Part 3. Okay, given that you form a GP, find P, so U5 we need to find, don't we? So U1 is equal to 80. U5, which is the second term of a GP, would be 85 minus 5 fives. Is that term, by the definition. 25, so that's 60. So we can see here that the first term of the GP, A, is equal to 80. The common ratio would be, what do you times 80 by to get to 60? Well, you times it by 60 over 80, which is 3/4. So there's our common ratio. So the second term of the GP is equal to the third term we want, don't we? We've just done the second term. So the third term is equal to AR squared, which is equal to 80 times R squared. And that needs to equal 80 minus 5n, because we want, or 5p, wasn't it? Because we're doing p as up. Okay, that's what we've got then. So what have we got? We've got 80 times 9 over 16 is equal to 80 minus 5p. 16 goes into 85 times. This is 45, but we can cancel by 5 all the way through. 16, and that goes. So that tells us then, move the p over here, and leave the 16 as is. Move the 9 over minus 9. And 16 minus 9 equals 7. P is equal to 7. And we found the value of P. And now we know that, we can find, let's find the sum to infinity as well, part 3. here. So S infinity is equal to A over the 1 minus R. A is 80, isn't it? 80 over 1 minus the common ratio, 1 minus 3/4, which is a quarter. 80 over quarter. The 4 swings up, 480s are 320. So S infinity is 320. Just looked over the question and double checked it all, and there's one slight mistake here. I've written down 80 minus 5p for UP, and if you look at the definition, it's 85 minus 5p it would be, wouldn't it? So I need to change that, and this will change the value of p. So let's just do it here then. So that'll be 85, and see how we go here. So this will be 17, won't it, if you divide by 5? So that would be 17 there. And this would be 17, of course. So that was 9. So 17 minus 9. And that's going to equal the value of 8. So let's put it in. So P equals 8. So apologies for that little error. But it's good to double check something in case a silly mistake has occurred, which it did here.